the ice caps about them is written in this book from the 70s. That they are at the North and South Pole a bit. At the South Pole at Antarctica, there is a 12 million square kilometer big ice cap, and at the center it's 3 kilometers high, and it covers almost completely Antarctica. And it goes from the center of Antarctica to the outside, and then it protrudes, floats on the water as ice shelf, and after the pack ice in the summer has melted, so the ice newly frozen in the last winter, then it breaks off as icebergs, which can be extremely big, and then it breaks further off and melts in the ocean. And there's a mountain range, and they are protruding with its peaks, and in the valleys between these peaks, there are glacier-like tons in them. And there are only growing mosses and lichens. There's also at the North Pole a little ice cap, and most of the ice is a lot of ice is on Greenland, and Greenland is 80% covered with this ice cap, but there's just 14% as much ice as on Antarctica. And that is according to the Reader's Digest Library of Modern Knowledge, Book 3, Part 22, The Regions of the Earth, written by Hugh Clayton, John Coyle, Michael Frenchman, and D.H. Sinclair, with page 1084 and 1085. If you discontinue to watch this video at one point, then please tell me what the reason for it was so that I can improve. Otherwise, hi and welcome. I'm trying to learn climatology, today ice cap, and after that Coniferous forest. And after we've done that, we're going to hip training. And if you participate in hip training, then it's already on risk. Ice cap. A great sheet of ice that covers more than 90% of Antarctica extends over 12 million square kilometers and is more than 3 kilometers thick in the center. So at the Antarctica, at the South Pole, it is to 90% covered with ice, and the ice is at the center 3 kilometers high, and it is on an area of 12 million square kilometers. The ice moves outwards from the pole. When it reaches the ocean, it floats to form an ice shelf, which eventually breaks off into icebergs in the summer after the pack ice has melted. I think I know what pack ice is. Pack ice is the ice which is freezing you on the ocean. That would now fit better with the explanation. But this is the second time we're reading the text, and we're a bit wondering what is pack ice. I think now pack ice is the ice which freezes new. And after the summer that new frozen ice has melted, the new icebergs are breaking off, the new ice shelves. When it reaches the coast, it floats to form an ice shelf, which eventually breaks up into icebergs in the summer after the pack ice has melted. So it comes when big parts of ice shelf break loose, which then further on breaking off into icebergs. And the floating forms are called ice shelf. I'm going to say it as it's written here. So when it reaches the ocean, when it is an ice shelf, and after the pack ice, the newly frozen ice of the summer has melted, then it breaks off as icebergs, which can be extremely gigantic at the Arctic. And there's also an idea to use these icebergs for fresh water. Around the edge of the southern continent, mountain ranges protrude through the ice. There's also a mountain range, I forgot what it was called. There's a mountain range, I once looked it up. There's a mountain range, and they're protruding, and in the valleys of these mountain ranges, there are glaciers lying. Glacier-like tons of ice descend the frost-shattered peaks, where only lichens and mosses can survive, and the only things where there are lichens and mosses are very small plants, or fungal plants, almost. The northern hemisphere's so large ice cap covers about 80% of Greenland and is less than 14% of the size of Antarctica's cap. And in the northern half there's also an ice cap, and that is on Greenland. Most of that ice cap, 80% of Greenland is covered with it, but it has just 10%, 14% of the size of one of Antarctica. Anything else? I think we have information. The caps are 12.5 million and 3,000 meters, going from center to the outside when the ice shelf breaks off after the pack ice had melted, and the things, then the glaciers between the mountain ranges, lesions, mosses, 80%, 40%. I'm going to start the camera, the second one, and I'll try to say it. The ice caps, there's written about the ice caps, about them is written in this book from the 70s. That they are at the North and South Pole a bit. At the South Pole at Antarctica, there is a 12 million square kilometer big ice cap, and at the center it's 3 kilometers high, and it covers almost completely Antarctica. And it goes from the center of Antarctica to the outside, and then it protrudes, floats on the water as ice shelf, and after the pack ice in the summer has melted, so the ice newly frozen in the last winter, then it breaks off as icebergs, which can be extremely big, and then it breaks further off and melts in the ocean. And there's a mountain range, and they are protruding with its peaks, and in the valleys between these peaks there are glacier-like tons in them, and they are only growing mosses and lesions. There's also at the North Pole a little ice cap, and most of the ice is a lot of ice is on Greenland, and Greenland is 80% covered with this ice cap, but there's just 14% as much ice as on Antarctica. And that is according to the Reader's Digest Library of Modern Knowledge, Book 3, Part 22, Regions of the Earth, written by Hugh Clayton, John Cole, Michael Frenchman, and D.H. Sinclair, on page 1084 and 1085. I'm going to stop here now. And let's read for the first time the other part. We're not going to go through it, but let's start with Coniferous forest, the other part. Coniferous forest is a broad belt of needle-leaved evergreen trees covering the higher latitudes of the northern hemisphere. They made a little error to it by saying the northern part of Russia and Canada. Let's look at Coniferous forest on the map. So it is the gray thing with the fir tree. That is in Northern America, in Canada, maybe a bit United States and Alaska. And then it is in Scandinavia, in Norway, Sweden, Finland, and then in Russia, in the Baltic countries, and in Russia, up in Siberia, a bit down into China, I would think, but I'm not sure. And there is it. Okay, the thing with all these forests in Canada and Russia mostly. So that is Coniferous forest, and that is a broad belt. It's pretty broad. It could be 2,000-3,000 kilometers. A broad belt of needle-leaved evergreen trees covering the higher latitudes of the northern hemisphere. So it is a 3,000 kilometer big area in which these fir trees grow. So they are all the year green with the leaves on them. And they don't have leaves like whatever plants have. They have needles, because it's a first. Or conifers. Its dominant species are spruce, fir, and pine, which grow in great stands. So the three trees mostly growing there are spruce, fir, and pine. In great stands. What does that mean? Very high. A thick layer of conifer needles covers the ground. That is interesting. I never thought about it. Imagine there's for tens of thousands of years. I don't know when the last ice. Maybe it was not that long, but for hundreds of years. What happens to all these needles? Now, a thick layer of conifer needles covers the ground. Soils are poor and acid because surface water leaches away nutrients. So there's not so good ground for things to grow. And also the ground is sour. It has a lot of acid in it. Because the surface water is leaches. I don't know what it means. It leaches away the nutrients. So the nutrients in the soil from which the trees would live are leached away by the surface water. And therefore trees don't grow. Winters are long and severe, the ground being frozen for most of the time. Okay, long and severe winters and the ground is almost all the time frozen. Even in the brief summer, the forest floor remains cool. For most of the year, moisture in the soil is not available for the trees because it is frozen. So when it is frozen, it is not available for the trees. So the trees are just standing there for 10 months or whatever, and they don't get water from the ground because it's frozen. Conifers survive because their needle leaves have a small surface area and a thick cuticle, which minimize the water loss by transpiration. Okay, these needles, and it makes sense. How do first get novel photosynthesis? Because I want to just say, trees have big plants, leaves, and they're losing a lot of water. And first they're having a small one. It's just a little needle, and they're having a thick cuticle in the middle, so they don't lose that much water. The leaves are changed only every 3 to 10 years, and then not altogether. So they're just losing every year a few of them, and they were already 3 or even 10 years old. And they don't lose all, they're losing just a few. Retention of leaves through the winter conserves nutrients. Retention is a word which can be used in normal language. Retention of leaves through the winter conserves nutrients. It is re-tenere, that is Latin. So it means to keep them longer, basically. Retention of leaves through the winter conserves nutrients so that the trees are ready to resume growth in the spring. So they are staying there, and as soon as when the summer hits in the spring, they can directly grow. So conifers grow fast and make useful trees for afforestation schemes. And that is why the people take these conifers and plant them somewhere else even, or even let them there. And then they're growing very fast because they're used to having just a few days to grow. However, I know that there's a big wood industry in northern Canada and so on. Maybe they're just standing there also, and also in the few weeks of winter they're growing, summer they're growing so strong that that's enough. But my other idea is now we're taking these trees with seeds which are growing normally very much north, taking them 2,000 kilometers more south, planting them, and these trees, they're having now much more summer and sun and water, but we're still thinking they have to grow very, very fast because they just have for a few weeks and they're growing immensely fast. Whatever. That was not all of conifer forests. That was the climatology part. If you were here for climatology, you can go directly to the next part of climatology, where we're going to read to the coniferous forests again, and also then the rest. If you stay here and participate in the Hiptraining, it's at your own risk. Have feet standing together and open the flat toes, the upper toes, the heels and the heels. The rooting tree exercise. As far as you can. And then again in. And this time stay down with the knees. So stay down. And together in. And up. Hip width apart, a bit down at the knees, a nonchalant dancing elephant. Flex the legs and press them together. Straighten one leg. Bend it again. Other leg straighten it. And bend it again. And up. Further apart. Down into the knees. Flex. Press together. Go over to one side. So that the leg straightens. Back into the middle. Over to the other side. Press together. Flex the whole time. Back into the middle. Up. Bit closer together. Press to the outside. One leg up. Hands up. Both. Switch. Middle. Down. Again up. Over. And down with one leg to the side with the toes into the ground. Lift the heel off the ground. Lift the foot off the ground. And up again. Flex your foot when it's up. Other leg. One hand on tummy, one lower back, and bring the leg up. Circling it high. And pull the leg up, toes down, and relax the leg. Another one. Bring the leg up. And pull the leg up. And now, I have more exercise. When heel onto the ground, just heel off the ground. Don't do it if you're pregnant. Over here. Stay anchored on one leg. This can go to the knee. Turn over to the leg. Up down. Turn over. Up again. Other leg. Turn over first. Down. Turn over slowly. Control. You can do the space lower and up again. And one leg up and bring it back. The seesaw airplane. Back. And the hiding airplane. Pull the leg. Knee in and out. In. Out. Other leg. Back. Leg high up. Back. And up. And the hiding airplane. Bring the knee in and out. And legs wide apart. Breathing it out. And breathe out. In and up. Out. Breathe in and close the legs. And breathing out. That was the hip training. I thank you very much and until next time.